Hello everyone, myself Dr. Santanu Kundu. I welcome you all to this lecture of soft computing techniques. This is the fifth lecture of module 11. So, in the earlier lectures, we have discussed about the rule generation on graph sets and also discussed some little bit problem of fuzzy graph sets. Today, we'll try to solve few more questions on fuzzy graph sets. If you recall, we have solved these questions. We have calculated the decision dependency of the weather attribute on the decision. So today we'll try to solve it on rain, that is the attribute B. So check the calculation. So this is the fuzzy sets weather, rain and traffic jam, and Q is the decision attribute. The following equivalence classes are obtained. Uh, that is for whether it is hot, mild, cold. We have discussed it. For rain, it is strong and weak. For traffic jam, it is long and short. For the for decision attribute, U by Q is AB, where A represents no. If you could recall the last example, so which is 1, 2, 6, 8, 14, and B represent yes, which is 3, 4, 5, 7, 9, 10, 11, 12, and 13. So here we calculate the degree of dependency of Q, that is the decision attribute, on B. Last class we have calculated on A. So let's check the calculations. So you know the formula for this is that first we need to calculate the lower approximation, so which is the mu B lower approximation x equal to supreme of F belongs to U by Q, that is you can write the F, that is weak, and for rain it is weak and strong, that is A belongs to Q, and F mu Fi x, and infimum of y belongs to U, maximum of mu Fi y and mu By. For here that we're calculating for the strong attribute, so we are calculating for the fuzzy set strong of the rain attribute. So here it is represents no. So here first we calculate the value of maximum of 1 minus mu Fy mu by. So mu by, so just check the table first. So for 1 the strong is 0 and this is also 1, so we need to calculate the value here, that 1 minus strong 0, so that is basically 0 is 1, and mu x1 that is also 1, so maximum of 1 is 1. Similarly for maximum of 1 minus mu f2 for strong, so for its value is 0.3 and its value is 1, so it is 1 minus 0.3, so that is 0.7 on 1, so maximum is 1. Similarly for the 3 day 3 we will get maximum 1 and 0. For day 4 we will get maximum of 1 and 0, maximum 1 and 0, and day 6 is maximum of 0.6. So here the membership value should be 0.4, so check it for 6. 6 is 0.4, so it is 1 minus 0.4 is 0.6 and 1. Similarly 0.8 is here, so that is for 7. This is for day 8, day 9. So here if we need to calculate the, we have calculated the maximum of this thing. Now we will calculate the infimum, the minimum of all these. So infimum of all these elements, the 1, 1, 1, 0.8, that, so you can check this is the minimum value. So here it is the 0.5. So up to we have calculated the value. So now we need to calculate the value of minimum of mu fi x and 0.5 for each x. So just to calculate here, so here for mu fx 0.5, so that is 0, so minimum is 0, 0.3, 0.5, minimum 0.3, minimum of 0 and 0.5 is 0, 0, 0.5, 0. So similarly we have calculated the value of this value. So we have calculated the value of these things, minimum of this. So this is the for the attribute of the strong. So similarly we have to calculate the same thing for the weak. So we for weak for the weak fuzzy sets, so maximum 1 minus mu fy mu by. So similarly we calculate that first maximum value, then see here the infimum value is 0. So if the infimum value is 0, definitely this value will also 0. You calculate the minimum of we have calculated the value of minimum of this value. We have calculated minimum of fix infimum of that. So this value is, if it is 0, so every value will be 0. So here all values are 0, as this value is 0. So next we need to find the value of uh, that f belongs to the strong and weak. So we need to find the maximum for strong and weak for the value of no. So here mu p lower approximation of 1 to 6 8 14, you have seen that the 0, because minimum is 0, so whatever we have obtained here, that will be the uh, maximum value, because here every value is 0. So this value is 0. For 1 it is 0, for 2 it is 0 0.3, for 3 it is 0, for 4 it is 0, for 5 it is 0, for 6 it is 0 0.4, for 7 it is 0 0.2, for 8 it is 0, for 9 it is 0, for 10 0, for 11 0.5, for 12 0.4, for 13 0, for 14 0.3. So we calculate the for no. The same thing we have to calculate for the yes, that is B. So here the same thing we have to calculate for the yes, so that is 3 4 5 7 9 10 11 12 13. So same we calculate the value of maximum 1 minus strong y, then you know that strong value is 0, so that is maximum 1 and 0 1, maximum of 0 0.7 0 0 0.7, maximum 1 and 1 is 1, maximum 1 and 1. So here the we need to calculate the infimum value. So here infimum value in this case is the 0.6. This is the infimum value. So then next we have to calculate the minimum of mu fx and 0.6. So that is 0, 0.6, minimum is 0, then 0.30, then 0 for 3, for 4 0, 5 also 0, for 6 0.4, for 7 0.2, for 8 0, 9 0, 10 0, 11 0.5, 12 0.4, 13 0 and 0.3. So that is the value. Now we need to calculate the for week. For week maximum 1 minus mu fi is that. So if you calculate here, the infimum value is 0. So if infimum value is 0, so the value we have calculated for the strong, that will be the maximum. So these value are the maximum for yes, so 0 0.3. Now we need to calculate the positive region. So positive region is that the membership value of the positive region of the partition Q with respect to the attribute B of each element is the supremum of the no and yes, that is for A and B. So if you calculate the supreme maximum value, for 1 you will get 0, for 2 you will get 0 0.3, for 3 it is 0, for 4 it is 0, 5 0, 6 0.4, 7 0.2, 8 0, 9 0, 10 0 and 11 0.5, 12 0.5, 13 0 and 14 0.3. Basically for these values are the same for A as well B, so the same value will be the maximum value, as these two are equal for all these things. So we'll get these values as a positive region. Now the degree of dependency of the attribute B with respect to the Q, you will find that this is the formula summation of all these values. So you need to sum all these values. So it is 0 0.3, 0 0.4, 0 0.7, 0 0.9, then it is 1.8, 2.1, and by the cardinal number of the all of the object set, that is the 14. So it is 2.1 divided 14 equal to 0.5. So that is the degree of dependence. You can calculate it for the attribute traffic jam. So this is another question, so you can write as example 2. So initially a rough set is given. So A attribute B, the attribute A, attribute B, attribute C, and this is the decision attribute. So sometimes is no, yes, no, yes, yes, no. So for if you write the no, then you will get the elements which is 1, 3, 6. For yes, you will get it 2, 4, 5. So right now it is just a rough set. Now we introduce the fuzzy sets. So here the fuzzy frequency is there. So this represents N, this represents Z. So we'll find that A become NA and ZA. So U by A is become NA and ZA. Similarly, U by B Similarly, you will get u by b as nb by z, u by b equal to nb and zp, like that. See also that. So this is the membership function. So if you see the graph, this x, this is mu x, so here 0.5, then this is 0, this is 0.5, this is 1, this is 0 minus 0.5 here. So this point is basically, you can write it, this is 1. So at 0.5 the value become 1, and 0 0 this becomes 0. So this straight line represents y minus 2x, this region, and this is 0.5 minus 0.50 these points, and this is 0 1, so it represents y equal to 2x plus 1, and this is a 0 1, and so this straight line represents y equal to minus 2x plus 1. So now here the value is for n a, this is 0 minus 0.4, so we will get it y equal to minus 2x, so that is 0.8. So that's it is 0.8 is here. Now for this is for n, now it is for za, then you need to find here 0.4 in this straight line. So you will get something like here you will get the value, so put the value here, you will get some value that is minus 0, so you'll get 0.2, like that. So this is the partitions or equivalence classes. So now we introduce the fuzzy set. So this has become that fuzzy uh, rough set. So this has become the fuzzy rough set. So initially rough set was there, we introduced the fuzziness in the attribute, so we'll get fuzzy rough set, and we got the value by the membership functions. So if you check this nb 0, for b it is 0.6, so for p it is minus 0.3, for n it will be minus 2x, so that will 0.6, and z will be like that. So z also will be in this formula, so we'll get the value. So these are the rough fuzzy sets. Now we need to calculate the maximum and minimum values. So just check it. So here equivalence class is 136, it represents no, and 245 represent yes. We need to calculate all these values. So this is the formula, mu over 13x equal to supremum of a belongs to u by a. So a basically u by a means n a and z a. So you have to calculate this for na and za, then minimum of mu fx, infimum of maximum of 1 minus mu fi, then mu all these things. So first to find this value, maximum of 1 minus that. So maximum of for 1 minus mu 1, so you know mu 1 mu na is 0.8, so it is 1 minus 0.8 means 0.2, and this value is 1.0. So maximum is 1.0 for attribute 2, so na2, so check the table, na2 also 0.8, so this is 0.2, and this value is 0, so the maximum value is 0.2. Similarly here also 0.4 and 1.0, maximum is these things, maximum is like. So here you can check, this is the minimum infimum value of these things. Now we need to find minimum of mu fx and 0.2. So this value is 0.2. Now find the mu na and 0.2. So here it is 0.2. Mu na and 0.2. This is 0.2. Mu na 0.2. This is 0.2. Let's this is 0. So the minimum value is 0, 0, 0. So that is for na. So we have calculated up to these things. Now we need to calculate the same thing for za. So za also same thing. Maximum of 1 minus mu zy. So mu 136 y. So 1 minus mu za1. So check the value of za1. So za1, the value is 0.2. So 0.2. So here you will get 1 minus 0.2. So that is 0.8 and 1. So the maximum value is 1. Here also maximum value is 0.8. So it is also 0.61. So it is 1. Then 0.61, 0.6. So here the infimum value is 0.4. So here infimum value is 0.4. Now we need to calculate minimum of mu fx and 0.4. So minimum is 0.2. Here also minimum of these things. So 0.2, 0.4, Here also 0.4, 0.4, 0.4. So that is for the attribute which is the uh, for for the attribute A. Calculate lower approximations of all these sets. So that is supremum of NA and ZA. So NA and ZA, first one value is both value are 0.2. So here we'll get the 0.2. Next is 0.2 for both values. So 0.2. Now for 3, here 0.4. They are also 0.2. So maximum is 0.4. So here all these values are now 0.4. So that is the value uh, for for the x equal to 136. Similarly, we need to calculate the value for x equal to 245. So if you do the calculation for x equal to 245, you will get the for 1 you'll get 0.2, for 2 you'll get 0.2, for 3 0.4, for 4 0.4, for 5 0.4, for 6 0.4. Yeah, both these two are equal. Now we need to find the positive the membership function of the positive region of attribute for the attribute A. The value of x is supreme of these two, so as these two are same, so we'll get the same value here. So the same value will be 0.2, 0.4 on that. So now degree of dependence is summation of all these values, so that is the summation 0.2, 0.4, so that is 2, and total the number of objects 2 by 6, so that is the degree of dependency. Similarly, if you calculate the degree of dependency for B, you will get 2.4 by 6, for C you will get 1.6 by 6. So now this is another fuzzy rough set. So attributes are A, B, C. This is the plan X, Y, Z. So here the thing is that these are the for these are fuzzy set A1, A2, A3, B1, B2, B3, C for C, C1, C2. Plan for X, Y, Z. So these are the plan for these things. So you need to calculate the dependency of attribute A for the plan, maybe for B and C also. So just check the question. So first of all, lower approximation need to determine. So consider the first feature in the data set. So setting P equal to U, produce the fuzzy partition U by P, that is A1, A2, A3. You know that setting Q is the plan. Produce the fuzzy partition U by Q is X, Y, Z. So first we need to find all these values by the formula. So similarly, minimum of infimum maximum 1 minus that. So all these value you calculate here. So that is mu a1x 0.6. Similarly, mu a2x 0.3 for a2 for mu 0.3. To calculate extend the object x in the dataset belongs to the fuzzy p lower approximation of x. The union of these values is calculated. For example, object 1 belongs to the lower approximation with a membership of these values supremum of all three. So that is 0.3. So similarly, you can calculate the value of all attribute like the previous calculations. So here you will find the positive region supremum is for 1 it is 0.3, for 2 it is 0.6, for 3 it is 0.3, for 4 it is 0.6, for 5 it is 0.5, for 6 it is 0.3, for 7 0.6, for 8 0.3, for 9 it is 0.3. So you need to calculate all these values like the previous calculations what we did in the last two questions. So solve these things and use the table. So here 9 elements are there, so total number of elements is 9, so that is 9. So now you know that degree of dependency of attribute P. If I say that A, so that on Q, that is plan equal to the summation of X belongs to U, the membership value of positive regions, and divided by total number of objects, so that is 9. So your summation is for it is 0.3, for it is 0.6, for it is 0.3, for 0.6, for 0.5, for 0.3, for 0.6, for 0.3 here, again it is 0.3. So total 9 is there, divided by total number of elements, that is 9. Now we need to add it. So if you add it, you will get it 0.9, 0.9. So that is 1.8, 2.6, then it is 3.8. So that is 3.8 by 9. So that is the degree of dependency. So please check the calculations. And so in this class, we have understood the fuzzy rough set and the method to calculate degree of dependency. In the last questions, we have calculated the degree of dependency of attribute A on plan. So you are requested to find the degree of dependency of attribute P on the plan, or you can also find degree of dependency of attribute C on plan. So solve these two questions. So these are the references of today's class. Thank you.